Thank you very much. So today I want to just talk a little bit and give a very brief introduction to a package that I've been working on now for a couple years. And this largely came out of a need that I had myself for automating some things. So I teach a variety of different classes, from very statistical computation classes to modeling classes to lower level undergraduate theory. One of the things that I like to do is sort of a central focus of all these things is the focus on computation as a useful skill set. And one of the things I want to encourage all my students to develop is a reproducible workflow. So pretty much universal to all of my classes, we're going to be doing stuff in our studio, and we're going to be running this on some kind of departmental or university server so that everything is centralized to make my life in terms of the management as simple as possible. So what we want to do is we want to give students starter code or templated R Markdown documents. We want them to work through that, and then at the end we need them to turn it in, we need to grade them. One of the things that I like to do, though, is say, well, if reproducibility is so important, I'm going to enforce this as one of the goals of the assignment. So when you turn in your homework to me, I don't want the HTML or the PDF document. I want the RMD. I want to be able to run it, and I want to get the same result you had as you work through it. And this makes the students have to work towards that goal. They see the value of the reproducibility as we go through it. So doing all of this is well and good, but if you're trying to do it on Blackboard or Learn or one of these other learning management systems, it's kind of a pain in the butt to have the students submit code there. Stuff doesn't work. So something that I settled on pretty quickly was, I want to use GitHub anyway. I use it for my own work. I want my students to use it. So let's just use GitHub as our learning management system. Have the students do all of their work, turn their code in there. We can then pull it down from there, grade it, and give them feedback via issues or something else like that. The problem is, as soon as you have a class of about 40 students, that gets pretty onerous pretty quickly because you have one repository per student per assignment, and clicking through things on the website kind of sucks really quickly. So something that ghclass came out of is this need to automate that process. So what I want to do is set up a structure where for each class, I'm going to set up a unique organization on GitHub. Within that organization, I will invite all of my students, so they will need to have a GitHub account. And then for each individual assignment, be it an individual or a team assignment, I will then create one repository with starter code and templates and everything else they need, all of that scaffolding, and I will create one repo per team per assignment throughout the semester. So that's my goal, and the package I'm going to introduce to you today, ghclass, is designed to try to make that as easy as possible to set things up, so you're not wearing your finger out clicking a bunch of buttons on the GitHub website. What I'm not going to talk about today is Worker. This is some continuous integration tools. This is a tool similar to Travis for automatic feedback, but it's a related thing. And when I pitched this talk for this conference, all of the Worker functions were actually part of ghclass. I pulled them out into their own package recently. So I've got previous talks. If you want to look at that or you want to chat up with me about automatic assessment, that kind of thing afterwards, offline, I'd be happy to do that. If you're not familiar, just to get some basic terminology clear, within a GitHub organization, there's sort of three main components, and things are just a little bit complicated because they all have many-to-many relationships with one another. So within an organization, you will have users. Those users have certain permissions of what they're allowed to do and what they're able to add and look at. Users then belong to particular repositories, but repositories also belong to teams, and users belong to teams. So largely, this is just about a large permission management system. Who gets to see what, who gets to modify what within this larger context. So when we're setting all of this stuff up, we need to worry about each of these three components and set them up in turn. And generally speaking, the way that we're going to do this is sort of have teams be the highest hierarchy. So we put students into the teams. The teams then own a single repository for a particular assignment, and that's going to control all my management, so they're not able to see their neighbor's code or anything else like that. So this is the larger context of what we're going to look at. Setting all of this up takes a little bit of time. You need to get things set up in terms of GitHub, so I've just provided some list of what you need to do here in terms of signing up for a GitHub account, making sure that you have access to the GitHub API via a personal access token, signing up for the GitHub education benefits so that you can create private repos for your students for free, and then create your organization for your class. The nice thing is these first three steps, they're not that onerous, and you only ever need to do them once. Once that's set up and working on your computer, you'll never have to think about them again, and you can create course after course, semester after semester as you go. And there's some useful links here, particularly Jenny Bryan's materials from Use This and Happy Git with R, super helpful for getting that access token stuff squared away the first time you do it. It can be a little bit frustrating the first time through. Okay, so ghclass, I had intended to get this on CRAN before the conference. I didn't quite get there, so currently it still lives just on GitHub. You can install it via remotes install GitHub, and it's under my username on GitHub, and then load the package. Just to give you some basic design principles behind it, All of the functions that are user-facing within the package are designed to have a prefix that tells you what the function operates on. So there are organization-related functions. Those are prefixed with org. Repo-related functions are prefixed with repo, so on and so forth. So the goal of this is to make things as discoverable as possible and also to have sort of simple function names that you can read and know exactly what they're going to do. Most functions are vectorized, so what that lets you do is I'm not going to create one repo at a time. I'm going to create a bunch of repos across a bunch of people. So I'm going to be able to do that with a single function call, and it's going to do a sort of a sensible thing in terms of repeating the short things, the usual kind of length coercion type things we expect with R, but in a reasonable way where we're not going to get sort of edge cases that we don't expect. The recent advance of useThis version 1.5 has lots of really nice, useful messaging things that prints out in a nice way to give feedback. So we've jumped on that wholeheartedly. We're using it, but that also means if you want to turn it off, you need to use the useThis.quiet option to set it true. And generally speaking, when you're working with GitHub, you're working with version control, most things are safe. There are a handful of dangerous functions in the package where you can do something destructive that's not good. The package will tell you, do you really want to do that first before you wipe out something that you didn't mean to wipe out or overwrite something you didn't mean to overwrite. And generally, we're sort of trying to follow a Unix design principle of simple tools that do one thing well, and that you can then get to more complicated behavior by composing them together, by stringing them together to do something more complicated. And I'll try to show you some examples of what that looks like today. Okay, so I'm going to be working through just a demo organization I've created for this purpose called ghclass-demo. So that's going to show up over and over again in the various function calls as we're referring to that. Generally speaking, your org name should be a little bit more useful and memorable to you. So I often do course number dash the semester that's in. So one of my previous statistical computing courses at Duke, Stat 323 dash spring 2019 is my name. So again, plan with multiple courses into the future. You're not going to teach something once. Make sure you don't overwrite things. And our made-up students for today are Anya, Bruno, Celine, Diego, Elijah, and Francis. And this is sort of an example of what you might have as a roster file at the beginning of some unique identifier for them, an email address, their GitHub username, and then the teams that I'm going to assign them for the first two homework assignments in this class. So I've come up with a naming scheme that's sort of consistent of homework as the prefix, their number, and then the team number that they belong to. So I've created my organization. Currently, not much exciting is going on. There's just 3 of us that are members of it, and these are the administrators. So the course teachers, the TAs, that kind of thing. So myself and Mina are there. And Therese, who's an RStudio intern who's working with us this summer, is also there. But there's no students, there's nothing else. So this is sort of the blank slate that you start with when you set up one of these organizations. And we're going to make sure that we can now go through and change things. So make sure your Git is set up. ghclass, so any function you see here is going to be from the package, has facilities for making sure that your tokens are set up correctly. So it's going to the GitHub API, making sure I can authenticate that everything works. But if I gave it like a bad token that doesn't work, it's going to give me a helpful error message saying, nope, your token failed to authenticate, you need to change it. So you can go back those previous steps. Okay, first step. Invite the students to the organization, org invite. We give them the organization we want to add them to, and then I just give them a vector of the GitHub usernames. It will then iterate through them and try to add them. So in this case, something went a little bit wrong. These first 4 members were not there already, but somehow I'd already invited Elijah and Francis and didn't clean things up properly. But I get a useful warning that they've already been invited, so they're pending members. I don't need to do anything else in this particular circumstance. I can then check the status of what organization members are doing. So in this case, there are no members who have joined the organization yet, excluding the admins, but I have all 6 of these students who are waiting to join at this point. So what's happened is GitHub has emailed them saying, you've been invited to this organization. Would you like to join? Click this button. So they need to accept that invitation before they become part of that process. And this is what it'll then look like. So admins are there, and we have 6 pending invitations, and I can see that they've been invited, and I can remove somebody or add them back. But again, this is just the web interface to see what it looks like on the website. A few days later, maybe some of my students have now accepted. So Anya, Bruno, Celine, and Diego have. Elijah and Francis haven't. And this always happens. There's a long tail of the distribution. Most of your students will accept right away. There's a handful that need regular prodding and saying, come on, please accept it so we can do everything else in the class. So I send emails out. That's why it's useful to have those in your roster file. Let them know that they should do this. And then eventually, hopefully, we've got everybody in our class. They're all there. So I have no pending members anymore. I've got everybody who's joined in. I know what's going on. Okay, they show up. They're now members. We now have 9 people there, 3 admins, 6 students. Next thing we're going to do is set up students. So just to remind you of what our roster looks like, I want to set up these teams. So if you notice, there's only 3 unique teams, but 6 values there. Again, we've tried to be reasonable about this kind of stuff. So if you say, I want to create the teams, and you give it a vector that has duplicates, it removes the duplicates and says, okay, you just want to create these 3 unique teams. We're going to do it. Again, giving you feedback about what team was created and where it was created, so you know what's going on. We can then invite the users. So I'm going to, again, team invite, the organization, the users I want to invite, and then what team I want to. And so again, it's just iterating over the 2 things. And so Anya was in team 1, Diego was in team 1, Bruno was in team 2, and it matches them in terms of their orders so that everything goes through. So now, notice I've got 3 teams. They're showing up. Each team has 2 members. They're now set to work on something or be assigned a repository for a particular assignment. Set up the repos. So in this case, what I generally recommend is have your team names be the same as your repo names. Makes everything a lot easier. So I want to create repos, repo create, the name of the repositories, and it creates them. And generally, we're going to use the same sort of conventions that DevTools or Remotes uses, which is going to be the organization / the repo name to refer to these things to make it easy to go through them. Once we've done that, we then want to add the teams to these repositories. So take the repos. I'm going to then use this org repos function to go out and dynamically from GitHub pull back what repositories exist within this organization, and then we have a helpful filter function that says, but once you get those results, filter them for only the ones that match this particular string pattern. So it just uses a simple regular expression to do that. And similarly, we can pull back our org teams to grab those, and then those will again be iterated over together to give us team 1 belongs to team 1 repo, team 2 belongs to team 2 repo, so on and so forth. So now we have repositories that belong to the teams, and the default process here is to set them up so that the teams have push access, so they can write to those repositories, they can make all those changes. The nice thing is that all of these repos are private by default, so they do not get shared with the outside world. The students' memberships in the teams is private by default, so again, we're not exposing any information either outside of the organization or within the organization about who's on what team, who's doing what work, so on and so forth. And for example, this is team 1, and right now not a lot is going on. We just give them a default sort of empty repository that's nothing is there. So that gets us started, but again, normally I don't want to just give them an empty repository. I want to give them some starter code. I want to give them a scaffold that says, this is what I want you to do for this particular assignment. So the way that we do that is through repo mirroring. So basically what you do is you set up a repository that has all the sample code. So in this case, I'm just taking the first homework assignment from my computing course. This happens to live in another organization, and that's perfectly fine. And what we're going to do is we're going to take that current state of that repository and then push it out to all of our team repositories. So I'm grabbing those with org repos again, and once I'm doing that, I'm saying take this source repo, push it out to all of those target repos, and due to some limitations of the GitHub API and my unwillingness to fight with the Git tree, what we do is we just clone that repo to your local machine shallowly, and then once we've done that, we then push that out to each of the individual team repos and then clean up after ourselves. And so what you get is something like this. So all of the content of that homework 1 repository now is copied into the homework 1 team 1 repository, so they have their own copy of all the files. We give them a README that describes the assignment. We give them an RMD that has a template for them to fill out, and so they can go through and work through it. So there's the README. All of this can be onerous a lot. We often want to do all of this together in one step, so there's a higher level create assignment function that does all of these things at one time to bring it all together. You can also create individual assignments. So I'm just leaving off the team argument, and in this case what I'm doing is creating one repo per individual, and then I'm adding the individual to the repository as opposed to adding a team to the repository. So in this case I'm now getting 6 different repositories, 6 different individual things that they can then work on. So this is very useful for doing exams, midterms, take-homes, that kind of thing. We can make changes, so if I want to push out a change to a file, I can do that. So in this case, I'm first changing the image for this FizzBuzz assignment from that to something huge. And then I can also modify things, so this is the modify where I can then make like a regex replacement change there, so I can change the assignment, because very often we're going to make mistakes in terms of that initial templated code, and we want something that's cleaner and fixing it up. At the end, if we want to grade their work, we just need to bring it locally. So we have functions for grabbing all those repositories, cloning them locally so that I can then run them on my local computer. I can compile the final output, look at that, get through it, and got a directory of all of those original homework 1s. Another kind of cool thing that we worked on recently is giving feedback via sort of style. So there's the styler package, which is fantastic for giving sort of automatic changes to the code, but I don't want to just change the code for the students themselves. So what this does is takes their repository, clones it locally, runs styler on it, makes a pull request from that, or makes a pull request from that branch and then pushes it back. And we're also leveraging a new feature within GitHub, which is draft pull requests, which means they get that pull request, but they can't merge it automatically. So they can just see the changes, but they can't just automatically click a button and say, yeah, that looks good, I want it. So what this looks like is we create an automatic pull request with some text that we put in. It tags the people who are relevant for it. And then we get something like this, which is the content saying, OK, here's where styler disagrees with the style that you actually used, and you can try to fix it. So put it all together. Future work, we've got a lot of stuff to do. Mina's working on a peer evaluation kind of thing this summer, which would be very, very cool. And automatic feedback stuff is coming in the future. Thank you very much.
Thank you, Colin. Questions? Okay, here and there. Okay. Sizzler around.
Hiya. Thanks, that's a great talk. Just a quick question. I was interested to see that you're creating a new organization for every year. Mm-hmm. And if all of us in the room create organizations for all of our courses for every year, that's a lot of GitHub organizations. So do you think there could be in the future a way of having a course organization that just iterates and you kind of update the content per year? Any comments on that? Welcome.
So this is something that I've wrestled with myself personally, and this goes back to the days when you made a request with GitHub Education to have free private repositories, you had to tell them how many you wanted ahead of time. And you're like, well, I really want one repo per assignment per student, but that's like 500. That seems like a big ask. I'm just going to say 20 and I can make do with that. The long and the short is like extra organizations, extra private repos, they cost GitHub almost nothing and they're very happy to give them to you. Yes, it crowds up your personal profile that I have like 30 organizations that I belong to. It's kind of annoying, but I do find the ability to organize it this way very nice. That way students can keep their work there. They can fork it and make it public later on for their own things. It just allows me to keep it without having to purge stuff as we go along. Now that I'm working in the UK and we have GDPR, that's not always possible. There's some other issues there. But I do find this particular approach works well. I know some other people have also done, so there's the master organization for that class, where they keep these sort of templates for each of the homework assignments and they work there. And then there's a version that's an organization that's just for each individual iteration of the course. And I think that works for some people well. I sort of just move things between them, but I think both are perfectly workable. But I don't see a compelling reason not to just create another organization unless you're really annoyed with the extra messiness of the too many organizations.
Thanks, that sounds good. And just to follow up, I also have loads of organizations and I figured out that if you don't publicize it, no one can see it other than you. So
yeah,
you can
that's the default with this. With
do you have to be public?
Please no discussion.
No.
We have some more questions. One more.
Your presentation was interesting and the topic is difficult to organize all the repos in the class. Do you know GitHub Classroom, I suppose? So how does it compare your solution to GitHub
when I started this, GitHub Classroom did not exist. And this was a much earlier version of this package where it was literally bash scripts on my hard drive. GitHub Classroom came along. I think GitHub Classroom is useful. I still use it in my class sometimes. It does very, very similar things. My main difficulty with it is how it handles group work. Their approach to that is that you let the students pick the team that they want to belong to, and that mostly works most of the time, but I wanted the ability to impose which teams the students were in, and that was not a feature of GitHub Classrooms. Early on, there's a little bit more facility to do it now, but it's not a first sort of, it's still a problem. So that's why I do things this way. But if you only have individual assignments, GitHub Classrooms is super easy because you just distribute it by an email, they click a link and everything just works. You don't need the extra infrastructure, but in spirit, these things are very similar, but GitHub Classroom fails you when you now have distributed the code, but you need to make a modification to one of the README files because you got the due date wrong. Again, there's no reason that you can't use both of these things together. I think they're complementary. This just came out of my particular needs and my particular use cases.
Okay, I'm very sorry we have one more talk, and so therefore please discuss in the break. Thank you very much, Colin, again.